Grade 12s, I welcome you to a series of lessons on this topic, inverse functions. Now this topic primarily depends on the information you acquired on functions in grade 10 and grade 11. Now maybe let's start by defining what a function is, although you have the idea of functions. So a function is a special kind of relation where for every x value there is at most one y value. That means if you relate the domain and the range, for every one value in the domain, we only have one value in the range. Now, if the relations are drawn graphically, if you draw a vertical line, it must only cut once and only once. If the vertical line cuts more than once, then that relation does not qualify to be a function. Now, from the relations that are there are two types of relations that qualify to be functions. Number one is one-to-one relation. Now, one-to-one relation, we are talking about the linear function and the exponential functions. For every x value, you get a y value. And then number two, it's many-to-one relation. That is the quadratic function. That means two values of x can give you one y value. Alright. Now let's look at the inverse of a linear function. The general form of the linear function, remember in grade 10 you used y is equal to ax plus q, and then when you started calculating the equation of a straight line, you started to use y is equal to mx plus c. Now there are two steps that you need to follow to find the inverse function. Number one is to interchange x and y. Number two, you make y the subject. The statement that you get is the inverse of the linear function. Now, about the notation, we use f for the function. The inverse is indicated by -1, which is written like a power, but it is not a power. It does not perform the duties of a power. It is just the notation. So we read this as inverse of f of x. Now let's go through an example and see if we can find the inverse of this function. We are given that y is equal to f of x, which is equal to 4x minus 3. Now, copying this as it is, the first thing we said we do is to interchange. Where there is y, we put x. Where there is x, we put y. Alright? So we have x is equal to 4y minus 3. Now, we make y the subject of this statement. So it means we have to add 3 to both sides. So we have x plus 3 is equal to 4y. Then we divide by 4 both sides so that we remain with y. So our y will be equal to x plus 3 all over 4, which means that the inverse of f of x will be x plus 3 over 4. You can further simplify this to a quarter of x plus 3 over 4 if you don't want to leave it as a fraction. So you find that even on quadratic functions you still follow the same process. On exponential functions you still follow the two steps. So don't forget these two steps on how to find the inverse of a function. This is what you need to remember. Now let's look at the two graphs. We have the graph of f of x and the equation of the inverse. Let's look at them graphically. How do they look if we draw them on the same set of axes? Alright, so here we are. This is the graph of f of x. This is the graph of the inverse. Now, the relation between these two graphs is that they are a reflection of each other along the line y is equal to x. And also, there are other things that we can notice. This point is negative 3, 0. This point is 0, 3 over 4. And now if we check, this point is 0, negative 3. This point is 3 over 4, 0. You can note the relation between these points, that for the function it's negative 3, 0. For the inverse it's 0, negative 3. That means that interchanging of x and y is all what happens when you want to draw the graph of the inverse. Alright, and also remember that there should be a reflection along the line y is equal to x. Now, maybe points to note. Inverse function graph is a reflection of the original graph along the line y is equal to x. The domain, that is the input values of the original function, is the range, that is the output values of the inverse function. Remember the interchanging. That means if we change x and y, x was the domain of the original function. Now the x has been changed to y. It means it's now the range of the inverse function, and the y for the original function has been the range. It's now changed to x. That means it becomes the domain of the inverse function. So basically we can say, in short, if we are having x, y, the coordinates, if we reflect it along the line y is equal to x, we'll get yx. So this is an additional part of the knowledge that maybe you didn't have, because you have been reflecting graphs along the x-axis, along the y-axis. So now you should also be able to reflect a point along the line y is equal to x, and you should be able to note the image by applying this relation. Alright, so it's now your time to go through an activity and see if you have understood this lesson. So I have 3 questions for you. Now for each of the following linear functions, you have to find the inverse function, and then you have to draw the graphs on the same set of axes. Remember to include the line y is equal to x. See you when we revise these activities. Bye bye.